Evaluate the integral sine of 8t minus 3 plus 20 cosine of 9t dt. And the second part, the integral of cosine of theta over sine squared theta d theta. Keep in mind that we cannot ever change the input of a function, and so we would need to work with the outer function. The antiderivative of sine is negative cosine, and so this is negative cosine of 8t minus 3, but even though we cannot change the inside of cosine, checking this, we would need to use the chain rule. The derivative of negative cosine is sine. So this is sine of 8t minus 3 times 8, but we don't have a factor of 8, and so we would multiply 1 over 8. And that is the result of the chain rule in reverse. If we take derivative, we would multiply a, so this is an antiderivative. We divide by 8. Similarly, we keep the constant multiple 20. The antiderivative of cosine is positive sine. 9t has to be 9t. Again, we cannot change the input of the function, but if we take the derivative of sine of 9t, we would have cosine of 9t times 9, and we don't have that factor 9, so we would need to multiply 1 over 9. And don't forget to add a plus c. Simplifying this, we have negative 1 over 8 cosine of 8t minus 3 plus 20 over 9 sine of 9t plus c. For the second part, very similar to the derivative, sometimes we will need to rewrite the integrand before we can recognize the antiderivative. And so if we rewrite it, this is the integral of cosine theta over sine theta times sine theta d theta. Rewriting this further, cosine theta over sine theta is cotangent of theta. 1 over sine theta is cosecant theta. But we know that the derivative of cosecant of theta is negative cosecant of theta, cotangent of theta, and so the antiderivative is negative cosecant of theta.